So let's go to Roman number 8. Equal chords cut off dash arcs. Equal chords cut off dash arcs. So let us draw the circle. This is a circle, center O. Am I clear? Equal chords. So let me take in two chords. Cut off. So for example, so this is AB chord. Two chords taken. So this is CD. So what I am given, equal chords cut off dash arcs, nothing but equal arcs. So here arc AB equals to arc CD. So then answer is equal arc. Am I clear? So let's go to Roman number 9. Perpendicular bisectors of a two non-parallel chords of a circle intersect each other at the dash of the circle. So what I am given? So let me take in one circle. This is a circle, center is O. Perpendicular bisectors of two non-parallel chords. So how to assume non-parallel chords? For example, this is a non-parallel. So this is AB is a one chord and CD. CD is a second chord. Two chords. So two non-parallel chords. These two are non-parallel chords of a circle intersect each other at the dash of the circle. So clearly we need to understand here. So AB. So let me take in that perpendicular bisects. That means by using the A, so at point A. So let me take in. So perpendicular bisect. That means it is a perpendicular bisect. So by using the compulse from A and B, we will draw the perpendicular bisect line just like that. This is a perpendicular bisect line. Okay, this is L. And also from CD by using the compulse. So compulse means just like that. So you can take from A and B. From A, we have to consider one point outside of the circle and inside. And by using the B, we will joining these 2 points. So it is a perpendicular bisect of AB. And same line taken perpendicular bisect of CD. This is a perpendicular bisect of CD. So this is a M. So clearly we need to understand perpendicular bisect of two non-parallel chords of a circle intersect each other. These two intersect each other at center. So center of the circle is required answer. Yes. So perpendicular bisect of two non-parallel chords of a circle intersect each other at which point? Center. So answer is center. Am I clear? So let's go to question number 10. If two circles intersect in two distinct points, the line joining their center is dash of their common chord. So in that question, what I am given? Two circles intersect in two distinct points, just like that. This is the first one. This is the second one. So they are two circles intersect different points, just like this is a distinct, nothing but different points. The line joining their centers. So this is the center of first one O. This is a center of second circle O bar. So line joining. This is a line joining centers. Okay. Line joining their centers is dash of the common chord. So this is a common chord. Here AB is a common chord. Am I clear? AB is a common chord. So AB is a common chord. So O and O dash are centers of first circle and second circle respectively. Am I clear? So what I am given, two circles intersect in two distinct points, nothing but different points. The line joining their centers dash of their common chord. So common chord, that means perpendicular bisect of the common chord. Then answer is perpendicular bisect. Perpendicular. This is a perpendicular symbol. Perpendicular bisects. Perpendicular bisectors or bisects. So this is a required answer. So this is a symbol of. So this perpendicular bisect means here forms 90 degree. It is also 90. It is also 90. It is also 90. Am I clear? So then answer is, so perpendicular bisects. Perpendicular bisects. So this is required answer. Am I clear? So let's go to question number Roman number 11. In a right triangle, the circumcenter is the dash of the hypotenuse. So here what I am given the word circumcenter. So before that, what is a circumcircle? A circle circumscribed in a triangle is called circumcircle. So that center is called circumcenter. Am I clear? So first one we can draw the right angle. So this is a right angle. ABC is a right angle. Am I clear? ABC is a right angle at B. So a circle circumscribed, just like that. This is a circumscribed. Yes, yes. It is a center of the circle. So this is a center point. Am I clear? So in a right angle triangle, okay, the circumcenter is the dash of the hypotenuse. So hypotenuse, here AC is a hypotenuse. Am I clear? So circumcenter, that means this is called circumcenter, is the dash. So in a right triangle, the circumcenter is the dash of the hypotenuse. So this is a midpoint of the hypotenuse. So then answer is midpoint is a required answer. Am I clear? So circumcenter means it is a midpoint of the hypotenuse. So it is also called circumcenter. So this is a circumcenter. So it is a midpoint of the hypotenuse. Then answer is midpoint is required answer. Let's go to question number 12. For an equilateral triangle, the circumcenter coincides with dash. So let us draw the equilateral triangle. So this is a equilateral triangle, nothing but all sides are equal. Am I clear? A, B, C is a equilateral triangle. Am I clear? The circumcenter. So clearly we need to understand circumcenter. Before that, what is a circumcircle? A circle circumscribed in a equilateral triangle is called circumcircle. Am I clear? Circumcircle. That center is called circumcenter. So just like that, circumscribed, not a inscribed, circumscribed, nothing but it will be appears outside of the triangle. So circle drawn outside of the triangle. So this is called circumcircle. So that center, how to form that center? So first one we need to take midpoints. So this is a midpoint of BC. So a line, a perpendicular line are drawn from vertex A to opposite line BC. So that is called midpoint. So same thing taken from B and C also. This is called circumcircle. It will be considered as a I. Okay. So that center is also called what is that? Centroid. It is also called. So for an equilateral triangle, the circumcircle coincide with the centroid. So this is called centroid. Am I clear? Centroid or orthocenter, in center. It is also called in center. Or also called orthocenter. So what I am given, for an equilateral triangle, the circumcenter coincide with the centroid G, in center or orthocenter. Am I clear? So this is important. Their answer is centroid, in center or orthocenter. So these are required answers. So let's go to Roman number 13. If the semicircle drawn with one side of a triangle as diameter passes through the opposite vertex, then the measure of a angle at a vertex is. So what I am given here, the semicircle drawn with a side of a triangle has diameter passes through the opposite vertex, then the measure of the angle at a vertex is. So draw the circle first. This is a circle, the semicircle, nothing but half of the circle. So this is called semicircle. Half of the circle is called semicircle, center O. This is a O. Am I clear? So this is a semicircle. Okay. So half of the part is semicircle. If the semicircle drawn with one side of a triangle, so this is a one side of a triangle. So let me take in one triangle also. So this is a triangle. So semicircle drawn with one side of a triangle. So this is one side of a triangle. Semicircle of a triangle. As the diameter passes through the vertex of the opposite vertex. This is opposite vertex. Am I clear? So what I am given here, a diameter. So firstly, semicircle drawn with one side of a triangle. So one side of triangle, this is a side of a triangle, one side of a triangle. So semicircle drawn, already drawn. Okay. The diameter passes through. So clearly we need to understand diameter, nothing but this is a diameter. So let me take in, this is ABC, is a triangle. AB is a diameter. Am I clear? AB is a diameter. Passes through the opposite vertex. Then the measure of the opposite. Then the measure of the angle at a vertex is. So this angle is asking at final. So this is always 90 degree because the angle. So clearly we need to understand the angle in a semicircle always 90 degree. The angle in a semicircle is 90 degree. Am I clear? Then answer is 90 degree. So the measure of the angle at the vertex is angle nothing but angle C equals to 90 degree. Am I clear? So let's go to question number Roman number 14. If opposite angles of a quadrilateral are supplementary, then that quadrilateral is called. So here what I am taking, ABCD is a quadrilateral. Am I clear? So opposite angles of a quadrilateral are supplementary. So supplementary angle means sum of the two angles equals to 180. Here opposite angles are supplementary, nothing but angle A plus angle C equals to 180 degree, or angle B plus angle D. So sum of the opposite angles here equals to supplementary, nothing but 180. So that quadrilateral is called cyclic quadrilateral. That's cyclic quadrilateral. Am I clear? So opposite angles of a quadrilateral are supplementary, nothing but angle A plus angle C equal to 180 as well as angle B plus angle D equal to 180. So then that quadrilateral is called cyclic quadrilateral. Am I clear? So what is the principles of cyclic quadrilateral? So some of the opposite angles are always supplementary, nothing but 180. That's quadrilateral is called cyclic quadrilateral. Am I clear? Let's go to question number 15, Roman number 15. Three non-collinear points describe a dash circle. So let us consider three non-collinear points. This is three non-collinear points. Describe a dash circles. You can add these three non-collinear points. You will get only unique circle. Then answer is unique circle. Okay, na? So three non-collinear points describe a dash circle, unique circle. Am I clear? So rest of the questions from the next exercise I will discuss you later. Thank you for watching my videos. Jai Hind.